Okay, this video is about how to write an electron configuration using the periodic table. As you can see, I color-coded the periodic table into 4 different blocks: the S block, the P block, the D block, and the F block. Now, one thing, I'm going to do some elements here, and some elements, when you get down further in the periodic table in certain groups, like the chromium group and the copper group, there are exceptions. But don't worry about the exceptions for right now. Just learn how to use the periodic table to write an electron configuration. So the first element I'm going to do is phosphorus. It's right here, number 15. Okay, so I'm going to always start at the beginning. And so this is 1 stands for like energy level number 1. And so you can go 1 and then you count. This is an S, so you go S and you count. You use the periodic table as a counting tool. 1, 2. So 1s2. Then I come down to energy level number 2. 2s 1 2. 2. See, I'm still at 2 here. 2. It's P. This is the P block. 1 2 3 4 5 6. 2p6. 3. So I write 3. S 1 2. 3 P 1 2 3. You stop when you get to phosphorus. If you add up all the exponents, which stands for the number of electrons, you should get 15, which is phosphorus. But you really don't have to do that if you use the periodic table as a counting tool. Alright, let's try another one here. Let's try iron, which is down here. Alright, so you always start at the beginning. So start at energy level 1, S orbital, count 1 2. 2 S 1 2. 2 P 1 2 3 4 5 6. 3 S 1 2. 3 P 1 2 3 4 5 6. 4 S 1 2. 3 D, this is the D block now, 1 2 3 4 5 6. Okay, now one thing to notice is that the D, the principal quantum number, or well, we'll just call it the energy level to make it simple, is one number behind the S's. Notice how it goes 4S and then 3D. Now I numbered the periodic table here, but when you do this for real on a test, you're not going to get a color-coded numbered periodic table. You just got to know that the D's are always one behind the S's. Okay, now I also want to show you a shortcut way. Instead of writing all this out all the time, there's a shorthand notation that you can use. So let's say we want to do iron the shorthand way. You back up to the nearest noble gas. So if you back up from iron, the nearest noble gas is argon. So you would put argon in brackets. And what that means is argon's electron configuration, which is all this right here. So if you just put argon in brackets, it means that right there. So then you just go from argon, 4s2, and then 3d, 6 again. That's a lot shorter way, and I would prefer that you would write them this way. It saves a lot of time. Okay, let's try a longer one now. Okay, so let's try iodine right here, but we're going to do it the shortcut way. So we back up to the nearest noble gas, which is krypton. So we go krypton in brackets, and then we go 5s2, 4d. Notice how the D block is one number behind or lower than the S block. And if you count, there's 10 across there. So 4d10. and then we go back to the P's, and the P's are always on the same level as the S's. 5P, 1, 2, 3, 4, 5. 5P, 5. Okay, let's try another one here. Okay, lead. Alright, lead is way down here. So let's do it the shorthand way. So we back up to the nearest noble gas. That's xenon, so we go Xe. And then we go 6S2. Okay, now here's kind of a problem. Watch carefully. So we go 5D, but look what happens. We got 57, but 58 is down here. So you go 5D1, and then you come down here and you got to do all these F's, because notice right here on the periodic table it goes 57, then it goes to 72. So you got to do the F's. Don't forget the F's. So 4F, 14. If you count, there's 14 in there. Okay, and then now the rest of the D's. So we would go 5D9, because if you count, there's 9 of them. And then 6P12. Okay, now notice the D's are always one number lower than the S's, and the F's are always one number lower than the D's when you're doing them in order. Now what you can also do, you could combine this 6S2, 5D10, 4F14. I just combined the D's. Okay, and then 6P2, oops, 2. Either way, I would count that right either way, if you, whatever way you do it there. All right, let's do one more. So let's do one down here, CF, okay? So it's way down here. So we're going to look at 98. You back up to the nearest noble gas, and that is 86. So you go Rn in brackets. So you go 7S2, if we pick up from Rn, 6D1, alright, but then after 89 comes 90, 5F, 1, 2, 3, 4, 5, 6, 7, 8, 9, 5F9. Now like I said, there are a lot of exceptions, especially the further down in the periodic table you go, so I'm not 100% sure that this is like californium's true electron configuration, but this is how it would work out just doing it the method that I showed you. So if you look it up and it's something different, it doesn't matter. I'm not going to give you super crazy ones like this necessarily that you got to know all the exceptions for, but you should be able to do it just following the order that I showed you here on this thing. That's it.